Hey kids, Miss Kulkarni here. In this video, we will continue with organic chemistry. And in fact, we will discuss some organic reactions. We will talk about the oxidation reactions of alcohols. But before that, let's find out how we classify the alcohols. The carbon atom is classified as primary, secondary, and tertiary. Look at the figures over here. The primary carbon is the one when it's connected to one carbon atom directly. A secondary carbon atom, which is in the middle here, is connected to two carbon atoms. And look at the tertiary. This is connected to three different carbon atoms. So you got the idea. Exactly same principle, we are going to take it to alcohols. So here, the hydrogen from the previous molecules is substituted by OH group here. And we classify the alcohols as primary, secondary, and tertiary. Now, all these molecules are alcohols. But when it comes to oxidation, they react differently. Let's find out how. But before that, I'm going to tell you how to identify easily an alcohol as primary, secondary, or tertiary. This alcohol here is primary, and I'm going to circle this carbon atom to which the OH group is attached. So what do we have here? We actually have CH2OH group there. Let's look at the next one. I'm going to circle again the carbon atom to which OH is attached. And what do we have? We got CHOH group. And now look at the tertiary and see what we have here. We got COH. So what are the key points here? In primary alcohol, we got two hydrogen atoms attached to carbon. In secondary, we only got one hydrogen atom attached to carbon. And in tertiary, there is none. When we talk about oxidation, which chemicals we are going to use? Normally, we use potassium dichromate, K2Cr2O7, or potassium permanganate, KMnO4, in some acidic medium. So let's find out how it is going to work with different types of alcohols. This is our primary alcohol with CH2OH group. When we oxidize it first, that gets converted to CHO. And what is the CHO group? That is an aldehyde. And if we continue the oxidation further, the group gets converted to COOH, which is actually a carboxylic acid. So it's an easy process by which we can take an alcohol and convert that to an acid. But that happens only when it is primary alcohol. Here is our secondary alcohol, and the group which we have is CHOH, one hydrogen atom attached to that carbon atom. When we oxidize that, what do we get? So look at this. We got two alkyl groups separated by a carbonyl group, and we call that as ketone. Now, if we continue to oxidize ketone further, unfortunately, there is no reaction. So, secondary alcohol is going to stop at ketone. What about tertiary alcohol? Whatever we do with tertiary alcohol, it is not going to show any reaction. So, anytime you see a group COH, you're going to always remember that has no reaction at all. Let's work on some examples now. Look at the alcohol here. What do we have? The ending group is CH2OH. That means this is a primary alcohol. So when we oxidize that, initially we are going to get alcohol converted to this aldehyde group, and at the end we are going to get the final compound as a carboxylic acid. Let's look at our second example. And we got here two alcohols. Look at the one here. This is primary. And if you look at this one, this is going to be secondary alcohol. So when we oxidize that, the end product, this is going to lead to an acid and this is going to lead to a ketone. So look at the end product. The primary alcohol here is converted to an carboxylic acid and the secondary alcohol is converted to this ketone. How about some more examples? Look at the alcohol here. We got two alcohols. If you look carefully, this is secondary alcohol because we got the group CHOH and over here the group is tertiary alcohol because there is no extra hydrogen atom. It's just simply COH. So when we oxidize this, I'm sure you remember the tertiary alcohol does not give any reaction. That means it's going to remain same and secondary turns into the ketone. So that's our final product. The secondary alcohol gave us ketone here and tertiary alcohol did not show any reaction. Let's work on one more example. But this is a cyclic alcohol and if you look carefully, that is primary alcohol and this alcohol here is connected to a carbon atom which still has one hydrogen atom. So if CHOH is the group, that makes it secondary alcohol. So if we oxidize this, the primary alcohol CH2OH will be converted to an aldehyde at first and then finally it will be oxidized to a carboxylic acid. Whereas when we get this secondary alcohol, that will be converted to a ketone. So that will be our final product. Don't you think it's easy? Alright, let's talk about breathalyzer test. This is a direct connection of oxidation reaction of alcohols with real life situation. So if there is drunk driving and if there is a suspicion about alcohol consumption, then this is an easy way to detect if person is under the influence of alcohol or not. So typically a person is asked to breathe into an analyzer which contains either dichromate or permanganate solution. Now they have a particular color. So dichromate has an orange color before and after it reacts with ethyl alcohol, it turns into chromium 3 which is green in color. Whereas permanganate is purple in color and after it reacts with ethyl alcohol, it turns into manganese 4 oxide which is brown in color. So just by observing the color change, we can confirm if the person has consumed alcohol or not. But just to warn you, it's a qualitative test. But ultimately, these are oxidation reactions of alcohols and we can represent these redox reactions in this fashion. So what do you think? You guys know how the oxidation reaction of alcohols work now. I hope you guys enjoyed the video. I'll see you in next video. Until then, bye bye.